So now we are going to solve problem 34. So this is problem 34, chapter 5, Halliday, 9th edition. All right. And what is this problem? Well, we have an incline. So let's try to make this the drawing here. We have this incline, and then we have a crate that we are pushing up along this incline. I'm going to make it just a dot here, but this is our box, okay? And how are we pushing it up with this force F, okay? I'm going to make it big so that it's easier for us to see when we decompose the vector. So this is our force F that is that we are using to move this box along the incline. They tell us what the angle of this incline is. So let's also mark it here. This angle here is 30 degrees. So you immediately see that this angle here is also 30 degrees. So this is good to keep track. And then the question is, well, they're saying there is no friction in this problem. Very good. The mass of this object is given to us. The mass of this box is 100 kilograms. This crate is 100 kilograms. And the question is, first, A, what is the magnitude of that force F that we just wrote? There is another very important piece of information, which is we are moving this crate up along the incline at constant, so repeat, constant speed. Constant speed means we are going along the incline, but acceleration is 0. This is very important, okay? So even though we are moving up along the incline, this is our V there, but constant, so acceleration is 0. Very well. So first question is, what is the magnitude of this F, this force that we are exerting, which is horizontal there? And next question, what is the force on the crate from the ramp? On the crate from the ramp, they are asking about normal force. Well, before we continue, then let's put these other forces, right? So we just talked about normal force. So let's put the normal force here. Normal force, always perpendicular to the surface, there it is. And the other force, which is always in these problems, well, the gravitational force, the weight. And this force is here pointing towards the center of Earth. Okay, so this is our mg, our gravitational force. So either you can write a gravitational force like that, or you can write mg. It's the same thing. Okay, and let me put my arrow in the normal force. So remember, this is a vector. Very well. How are we going to solve this problem now? We have to choose a reference frame. As we said, in these problems of the incline, it's very convenient to put one of the axes of the frame along the motion, along the direction of the motion. So the motion is along this incline. So I'm going to choose as my frame, this is going to be my x-axis, okay? So this is my x-axis, and this is our y-axis. So the normal force is along the y-axis. The other force as well, we have to be patient and we have to decompose those vectors, the F and the gravitational force. Well, to decompose the F, I already put the angle there, the 30 degrees, so that will be useful for us. How about the gravitational force? Well, let's have a look. Remember what we said in class. Now, if I think about a triangle here, this is 90 degrees, right? This is 90 degrees, this is 30. In the sum of all the angles in a triangle has to be 180. So this angle here is 90 minus 30, or 60 degrees. No? So 60 plus 30 plus 90 is 180 degrees. Very well. Well, if this is 60, I could also say, well, I know that then this is 30. Okay, you choose now which angle you want to play with. I'm going to be playing with the 30 degrees. Okay, so I'm going even to eliminate this 60 of this story because I'm going to play with that 30 degrees. You decide which angle you prefer. Thinking about that 30 degrees that I wrote, how am I going to decompose that vector? How are we going to decompose, let me get a different color. How are we going to decompose this gravitational force? Well, when we are thinking about decomposing a vector, always remember that vector is the hypotenuse. Okay, so you'll have to make a triangle so that that vector is our hypotenuse. Okay, so if I want to find the components of the gravitational force, I'm going to make my triangle parallel. So one side here parallel to the x-axis, the other side here parallel to the y-axis. So this is my component of the gravitational force in the y direction. And this is my component of the gravitational force in the x direction. Okay? All right. Thinking about this triangle that I just drew here, right? This right triangle that I just drew here so that my gravitational force in red is the hypotenuse. I can go now and find out what are those components. So this component of the gravitational force in the y direction, what is it? Look at our angle. Look at our component. Our component is adjacent to the angle. So our component is the hypotenuse, the mg, which is the gravitational force, cosine of 30 degrees. If you don't see that immediately, okay, let's write what cosine of 30 degrees is. I'm thinking about this angle here. Huh? So what is the cosine of that angle? Is the adjacent. What is the adjacent? The gravitational force in the y direction divided by the hypotenuse. What is the hypotenuse? This whole thing here. Huh? So I can write it here. This whole thing is the hypotenuse, which is the gravitational force, which is the mg. Yeah? So in other words, the cosine of 30 degrees is that component that I'm after, the component in the y direction divided by mg. This is what I wrote here. All right. Okay, so I got my component of the gravitational force in the y direction. And yes, in the y direction is a cosine because the y direction here, the y direction is adjacent to that angle, is touching that angle 30 degrees. Yeah. Now, how about the x component? Well, the x component is this one. Yes. So this is the x component. You see here the x component. And this is opposite to the angle. So how are we going to write this component of the gravitational force in the x direction? Well, is the mg, the gravitational force, but opposite. So it's sine of 30 degrees. Okay. So this is good. We found the components for the gravitational force. Okay, how about the other force that we have to decompose, the F? Okay, so again, the same story. F is the hypotenuse. The other sides of my triangle are the components. So how I'm going to make this triangle? I make a line here parallel to the y-axis. Here I have a line parallel to the x-axis. So here is my right triangle. This is going to be our component in the x direction. This is our component in the y direction. Okay, so let me make a better color here. This is our F, that we are trying to find along the x direction. This is our F along the y direction. Now, in this triangle here, then you see that the y component is opposite to this angle 30 degrees. Oh, there, yes, that Fy is opposite. So in that case, it's going to be F, and then we have opposite, so sine of 30 degrees. And this component in the x direction, that component will be adjacent, touching the angle. So F cosine of 30 degrees. Okay, so this is just the discussion about decomposing those two forces. But now let's go for Newton's equation. All right, so I'm going to start writing the sum of all the forces in the x direction. Remember what the x direction is here. Yeah. Sum of all the forces in the x direction is equal to max. Okay, let's see what we have in the x direction. As you see in the drawing, we have this fx component, right? So, and this fx component is this. The fx component is along the x direction, so I'm going to put here plus that component of the force F plus, and it's going to be F, here it is, cosine of 30 degrees. Okay, what else do we have in the x direction? Well, look, this component here of the gravitational force, let me mark here so you can see, this is also along the x direction, although careful because it's pointing opposite to the direction of the x direction of the frame, right? So here we have minus, because it's opposite to the direction of my frame, and minus this x component here. What is this? This component mg sine of 30 degrees, okay? So this is all that we have on the left side of the equation. All right, how about on the right side of the equation? The right side of the equation is ma. But what is a? Well, we said that a is constant, well, speed is constant, so a is just 0. So on the right side, 0. And so you have everything that you need to find what is the value of f, what is the magnitude of this f. You have m, it's 100, you have g, 9.8. Remember, we already took into account the direction, so here you're just going to put the number, just the magnitude 9.8. Sine of 30 degrees, cosine of 30 degrees, so you solve all that to get 566 newtons. This is the force, and that horizontal force, that's the magnitude of the horizontal force. This is part A of the problem. Part B of the problem, and we can get some more space here. Part B of the problem is, okay, how about the normal force? Well, the normal force only shows up in the y direction. So we have to go for Newton's law, Newton's second law in the right direction. So sum of all the forces in the y direction equals to MAY. Okay, what are the forces that we have in the y direction? Well, the force that is pointing up is the Fn. So we have here plus Fn in the y direction. What else do we have? We have this component here of the gravitational force that's in the y direction, is pointing down, so it's negative. So this is the one that I'm going to write now, is minus mg cosine of 30 degrees. Okay, so the gravitational force in the y direction is cosine. Yes, it's cosine because we are adjacent to the angle that we chose, and it's minus because it's pointing down according to the y-axis. What else do we have? This component here, this fy component, which is also pointing down. And what is that? This one here. So here we have minus f sine of 30 degrees. Equal to what? Well, there is nothing in the y direction. There is no motion even in the y direction, so acceleration 0. Yeah? So there we have everything that we need to get the value of this Fn. So if you put the numbers there, you'll see that this Fn is 1.13 10 to 3, so a little bit more than 1,000 newtons. And that's the end of the problem.